Hello, Math 10C. This is a video that I've put together about writing equations using y equals mx plus b. This follows along with your equations of linear relations lesson number 2. It can be found on page 563. So take a second to find that page. We're going to set ourselves up to complete all of the examples. You'll follow along with me as I complete the notes, and I'll try to explain as best I can, and then we'll assign some homework questions at the end. Okay, so at the top here, underneath the review heading, it says, we have learned that the graph of the equation in the form y equals mx plus b is a straight line with slope m and y-intercept b. And so that was the whole point of yesterday's lesson, to say if you see this form mx plus b, first, the equation is linear. That means the graph would draw a straight line. And second, m refers to the slope, b refers to the y-intercept. So how do we use that then to write a line? So if we are given either the slope or the y-intercept or both, we should be able to write the equation of the line. So in class example number 1, write the equation of a line passing through the point 0, 2 with slope 5/2. And so my goal is to write it in the form mx plus b. So I'm going to start by writing y equals mx plus b. They tell me right here slope 5/2, which tells me my value of m is 5/2. So I know that.
Mrs. Kosh, could you call the office, please? Mrs. Kosh.
Sorry about that. Okay. Second thing, we want to know what's so special about this point. And so my guess is, because I'm supposed to be writing a slope y-intercept point, it's likely that that's my y-intercept. I'm just going to verify that with a quick sketch over here. So I do a quick sketch and I say the point 0, so that's an x, comma y pair, 0, 2. Yes, that lies on the y-axis. That's my y-intercept. So now I know that my b value is positive 2. And so I go to write the equation y equals 5/2x, slope mx plus 2, plus my y-intercept. And that has answered the question. We wrote the equation of the line. We weren't asked to analyze it any further, so we're done. Class example number 2. Each line on the grid passes through points with integer coordinates. In each case, state the slope and the y-intercept of the line and write the equation of the line. Okay, I want to go first. Why did they tell me that they had to be integer coordinates? So they did that on purpose. They did that so that when you're looking at points, mainly at your y-intercept, maybe your x-intercept or anything like that, you should know that some of these points you're trying to determine slope, for example, there's more than one point on these lines that have perfect integer coordinates, meaning there's not decimals, they're not fractions. You shouldn't have to guess and say, oh, maybe this is at -4.1. Well, it's probably at -4 because it's integer coordinates. So we're going to go here. Say, in each case, what is the slope and y-intercept of the line? If you look very closely, you're going to see a little L1 down here. That's going to be line 1, and L2 is going to be line 2. So I'm going to go right away and write line 1, line 2, so I can sort for myself which one I'm working with. So line 1 is going to be the one with the little L1. I need to know the slope and the y-intercept of that line. So I need to know, what is the slope? What is the y-intercept? What is m and b? Same thing for line 2. And so if I look at line 1 here, I'm trying to find the slope. I can pick any 2 points on the line. I know that slope should be the same no matter which 2 points I choose. I'm going to choose from here to here. And I see we are going over 3, up 1. So rise over run. I'm going up 1, positive 1, for a run of 3 to the right. So I've drawn my little right triangle there. Up 1 over 3. Okay. My y-intercept is right here where it crosses the y-axis. That's at -4. It's just one above -5. So that's going to be -4. And my slope of my line, then if I'm going to state this, the equation of the line, what is the y equals equation for line 1, L1? Y equals mx 1/3 x plus b. B is -4, so 1/3 x minus 4. Okay. I'm going to go over to line 2. I'm going to do the exact same thing. If we remember the idea that something that is falling to the right, so as we're looking in the direction that you would typically read, and it looks like it's falling, it has to have a negative slope. So I'm just doing a quick mental check right now. Okay, now I know slope for this line is going to have to be negative, but what's the number? And so I'm going to check again here. I see I'm going down 3 over 2. If I draw a little right triangle, any 2 points on the line, I chose right here and right here. So I went down 3 over 2. My rise over run, -3 over 2. Alternatively, you could have looked at it as to the left 2 and up 3, in which case the negative would be in the denominator, but it doesn't change it at all. I just know m is negative, slope is negative. So -3/2 x for my equation plus b. My b value is my y-intercept. That's right here, crossing the y-axis, that's at +2. So -3/2 x plus 2. Okay, so I've given you in class example 1 some characteristics of the line. Write the equation. Class example number 2, some graphs. Write the equations. And now we're going to look a little bit further. Determine the equation of the following lines in A. The line parallel to y equals 1/3 x plus 4 with the same y-intercept as y equals 6x minus 7. Let's break that down in half. I'm going to draw like just a line right through that and. I'm going to treat those as two kind of cases. Parallel to y equals 1/3 x plus 4. Recall that to be parallel, that means you have to have the same slope. Or I could reword that to say the same m value. M here is 1/3. M of my line is going to be 1/3. The same y-intercept as this line. This is the second part. So first we had to use this equation to get our slope. The same y-intercept as this line. Well, this line, the b value on the back is -7. So my line has to have the same y-intercept, has to have a y-intercept of -7. I've got my m value, I've got my b. Can go ahead and write my answer. Y equals 1/3 x minus 7. And we're done A. Let's go to B. Line passing through 0, 9, perpendicular to the line joining to -6 and -5, 0. Okay, the line passing through 0, 9, that 0, 9 is x is 0, y is 9. That's a y-intercept. And I see that the y value of the y-intercept is +9, so I know already the b value of this equation I'm about to write is 9. But here's the tricky part, or almost the second criteria of my line. Perpendicular to the line joining to -6 and -5, 0. Okay, and when I'm given 2 points, I have no idea what the slope is, and I don't really feel like drawing it. So I'm going to go around that and say I have an algebraic way of finding the slope. Looks like y2 minus y1, or the slope formula, over x2 minus x1. So I'm going to go in here. I can name which ones I want to be x1, x2, and y1, y2. So I'm going to go, let's say this is x1, y1, x2, y2. I'm going to plug in y2, 0 minus y1, -6, over x2, -5, subtract x1, 2. 0 minus -6, the double negative makes that +6. -5 subtract 2 is -7. So my slope of these, between these 2 points, is 6 over -7, or -6/7. But I was told this line that I'm about to write the equation to has to be perpendicular to that. So the slope of the line perpendicular to that, if we remember what it means to be perpendicular, this is the negative reciprocal. Okay, or we could say the negative flip. 6 divided by negative 7, flip it and change the sign. Positive 7 over 6 is the slope that I need. This is the m value for the line I need. This is the b value for my line that I'm drawing or about to state the equation to. Y equals 7 over 6x plus 9. Okay, that was a harder example. That would be about the most difficult that you would see in this unit. Okay, let's flip the page here. Class example number 4. We see a display from a graphing calculator. Oh, sorry, at the top. See the display from the graphing calculator. The intercepts are integers. Determine the equation of the line shown. And they tell me that there's a scale. If I look down here, x scale is going up by 5, which means every time I see a tick here, that should be going up by 5. And the y scale, looking here, y scale is 7, which means my first tick is at 7 and the second tick is at 14. Okay, so if I want to look at this now, I've labeled enough information for me to decide what the slope is, what the y-intercept is. And so when I'm looking at slope, I'm going to go back to how I would determine it graphically. Rise over run. Rising, or in this case falling, 14, because it's falling to the right, so it's going to be negative, going down 14 over 20. So I'm going to say rise, negative 14, down 14, positive 20 for a run. I would math fraction this or simplify it on my calculator to negative 7/10, dividing them both by 2. And the b values, the y-intercept, well, I can see it goes right through that second tick on the y-axis. So my b is 14. That means the equation of my line must be y equals negative 7/10 x plus 14, mx plus b. Okay, step away from what we would call oblique lines for a second, horizontal and vertical lines. And so it's kind of difficult to see on my page here. Hopefully your book's a little clear. I can see in L1 this horizontal line right here. This L2 is the one at the bottom, and then L3 is vertically right here. And so ask you to go through and write what is the slope, what is the y-intercept for these lines, L1, L2, L3. So in A, state the slope and y-intercept of the horizontal line L1. If I'm looking at L1, it's rising, or here it's horizontal. There is no rise, or a rise is 0 for every 1 you move over. So I would think rise over run, 0 over 1. And if I remember, horizontal lines have a slope of 0. I cannot use my formula, or I can just remember this fact that horizontal lines have a slope of 0. I can say the slope of L1 is 0. The y-intercept, where it crosses the y-axis, right here, is positive 4. Use this equation to determine the equation of the horizontal line L1. Well, if my slope is 0, that means mx, 0x plus 4, and 0 times anything is 0. So I just say I have the line y equals 4. And so this makes sense because it doesn't matter what x is along L1. It doesn't matter how far to the left and right you go. Y is still 4. So if y is still 4, the equation y equals 4 makes sense. All x values, y is 4. And using that pattern, write the equation for L2. Well, this was y equals 4, where 4 was my y-intercept. Here, that's at negative 6. I'm going to go ahead and state that on L2, the formula is y equals negative 6. That would graph me a straight line through negative 6. No matter what x is, y is negative 6. Okay. things get a little trickier when we go into vertical lines. And so when I start looking at this L3, a vertical line on the grid, says state the slope in the y-intercept. Well, I can see this is almost running parallel to the y-axis. There's going to be no y-intercept ever. It's never going to meet. So there's no y-intercept, or I say y-intercept none. State the slope. Well, the slope, rise 1 over 0. 1 over 0. Can't divide by 0. If I remember, we said that this means slope is undefined. So now I have an undefined slope, no y-intercept at all. I can't even write 0 in there because that would indicate that it was going through 0. So it says, how can you not use mx plus b to determine the equation? Well, we don't have finite values. Finite means almost existing, that you could measure, opposite of infinite. We don't have a finite value for m. Okay, it wouldn't really matter for a second that we could say that y equals m, x plus b. It wouldn't really matter that we could say plus b. We could say there's no y-intercept, but I need to indicate that here, and I'm going to do that by switching the form of this equation. And so I was saying before, okay, no matter what x is, y is positive 4 or negative 6 in the case of L1 and L2. I'm going to switch that and say, for a vertical line, this is not a y equals line. This is an x equals line. X equals, and x always is negative 3, no matter what y is. Okay, so the equation of the line that I would try to graph would have to be in the form y equals mx plus b. So why can I not use a graphing calculator? Well, there's no y equals. That's my big problem because I pushed the button y equals to graph. But I'm going to know then that anything with x equals is going to be a vertical line. And so there's a little box at the bottom that summarizes that. The equation y equals k represents a horizontal line through 0, k, where k is the y-intercept. And the equation x equals k represents a vertical line through k, 0, where k is the x-intercept. And we have one last question related to horizontal and vertical lines. When we're trying to write these, it might sort of help you to talk yourself through, as I have been saying, well, if x goes forever to the left and right, does it matter or does it not matter what x is? Or does it matter what y is or not? Is it changing? Whichever one is not changing is the equation of your function. I hope that made a little bit of sense. Okay, at the very, very top of the next page, a very short example. Can you determine the equation of the line through the point negative 2, 8, parallel to the y-axis and parallel to the x-axis? Parallel to the y-axis. My y-axis runs vertically, while x runs horizontally. So if I'm going to be parallel to the y-axis, this is a vertical line. And that means parallel to the x-axis is a horizontal line. Okay, and I can either go from memory or flip back for a quick second to the bottom of the last page, that box we just looked at. It says the equation of a horizontal line, y equals. So I'm going to go right here, y equals, for a horizontal line, x equals something is a vertical line. Okay, so I got x equals, y equals written down there. And so if I think about this, if you're a horizontal line, you're staying at the same y value forever. If you're a vertical line, you're staying at the same x value forever. I just have to decide what those values are. And at the top here, this point, x comma y, is going to help me do that. X is negative 2, y is 8. So I'm going to go here. X is always equal to negative 2, y always equal to 8. And that would be enough to say that this line, vertical line through negative 2, would go through that point as well as be vertical because of the x equals. Parallel to the x-axis means horizontal, so y equals line would be the horizontal line going through that point at y equals 8. Doesn't matter what x is, y is still 8. Okay. All right, so we're finished our lesson 2, writing equations using mx plus b. Let's go and pick a couple questions, and I don't have all the pages printed here, so I'm just going to kind of go through and pick and choose and write for you what questions I want. So for your assignment, let's do let's do half of number 1. All of number 2. Okay, we're going to do number 4, number 5, and 6, as well as, let's try number 9. That's about horizontal and vertical lines. So my list here, 1, 2, or sorry, half of 1, put that in brackets so you can see it there. Half of number 1, 2, 4, 5, 6, 9. And then I'm going to give you the hint here that probably a good idea to go ahead and do all the multiple choice. And when I mean do the multiple choice, I don't mean go through and look at the back and say, oh, it's A, I did it. I mean try it out, because I wrote a lot of my questions on the assignment and on the test to mimic the form of the multiple choice, or to look very similar to the multiple choice in the book. So all I did was, oh, okay, that's a nice question. Maybe I should change the number, and you've got the same style of question. So if you go through the multiple choice in lesson number 2, you'll be well on your way to answering questions related to y equals mx plus b. All right, thanks for watching. Get to work.